All right, guys, so after we spent a really long time going through what I called section 3.8a, which was really just kind of refreshing us on a lot of things that hopefully we learned and maybe even remembered some of from last year in Algebra 1, we're now finally ready to move on into the real purpose of this section being here in this chapter in geometry. So 3.8b is on the slope and equations of parallel and perpendicular lines. We didn't really talk about those words at all in 3.8a, but that's the real reason that this section belongs here where it is in chapter 3. We were talking about parallel and perpendicular earlier, and we're getting back to it right now. So the first big idea that we have here today probably should be a theorem, but it's just kind of listed as a statement of fact right here, guys. Parallel lines have equal slopes, and I'll come back and I'll talk about this idea here in just a second, but I want to focus on this one here first. All lines that are going to be parallel have to have the same slope. And you can kind of read that as what we call a biconditional statement. It kind of goes in both directions. Now, just to illustrate real quickly what's going on right here, if we took a look at a graph, if I were to choose two random points, like maybe this point right here, I'm not even going to think about what the coordinates are, and this point right over here, there's only one line that connects those 2 points, and it looks something like that. So there's a line defined by 2 points on a curve. Now, what I could do, that would be pretty quick and pretty easy right here, guys, would be to say, all right, I'm going to take one of those points and maybe just drop it, let's say, down by 1, 2, 3, 4 units and kind of put this point right over here. Now, if I were to talk about right here the slope of that blue line, what I'd probably do is measure the distances here from point A to point B, rise over run. So it looks like here we are going up 1, 2, 3, 4 units right there. So it looks like from A to B, our rise is going to be 4, and our run then is going to be 1, 2, 3, 4, 5, 6, 7, 8. It looks like our run is going to be 8 there. Now, if I did that exact same thing with a second line right underneath that, let me see if I can do what I'm hoping to do right here, guys. If I can clone this line, can I do that here? Let's see if I were to copy and then paste it here somewhere else. Let's see. There we go. Okay, what I think that does for me now is it gives me another line that, yeah, is both congruent and parallel to that line that I started with. And if I pass it through that first purple point that I had right here, maybe I'll call that point C. Let's take a look here, guys. Point D looks like it's also going to be 4 units below point B there. So here we go. Now, what I'm hoping you guys notice here is that these two lines are parallel to each other. But what we haven't talked about yet is what is the slope of that second line of CD. So to get from C to D, let me switch colors here, maybe to green, I would have to go up 1, 2, 3, 4 units there. So again, my rise is 4, and my run to get to D, 1, 2, 3, 4, 5, 6, 7, 8, is going to be 8 also to get from C to D. So what do we see here, guys? The slope of line CD, rise over run, is 4 over 8, which of course simplifies to 1/2. And if I switch back to red now, the slope of line AB right there is this 4 over this 8, which again also simplifies to 1/2. So the point I'm trying to make here that I hope you guys see is that if these two lines are going to be parallel to each other, their slopes are going to end up exactly the same. So that's where this statement comes from, guys. Parallel lines have equal slopes. I said we'd come back and talk about this in a minute. We feel the need to put this statement here in parentheses. All vertical lines are parallel because technically vertical lines don't have slopes, if you recall. The slope of a vertical line, which we talked about in section 3.8a, is undefined. So if we were to draw two vertical lines, one that looks like this and another one right next to it that looks like that, you can't say that these two vertical lines have the same slope because their slopes are undefined. And two undefined quantities cannot be equal to each other. So Really, what we probably should have said with this statement right here is parallel non-vertical lines have equal slopes, and then also added this statement here, but I think everybody gets it at that point. Okay, so parallel lines have equal slopes, and now that we've established that fact, most of what we're going to do from here on out in this section is going to feel really similar to what we were doing in 3.8a, finding equations of lines. So let's take a look at A here. Find the equation of the line. Notice the line, there's only one, that is parallel to y is equal to negative 3x minus 2, and that contains the point 2, 3. Okay, so what we're doing in a problem like this, and I drew the graph right here, but that's really just going to be a way to kind of verify our answer when we're done. We're going to do this one algebraically. And the first thing we need to determine is that they gave us a line right here that is in slope-intercept form. We can see that because it's solved for y, and what we need is the slope of that line that they gave us right there. From slope-intercept form, slope is just the coefficient of x, which is going to be negative 3 in this case. And then what I like to do, and I'd like to encourage you guys to do this as well, is write another m, but then with a parallel symbol right after it. Slope parallel here. So if the line they gave us had a slope of negative 3, what's going to be the slope of any line parallel to that? Well, we just got done discussing that parallel lines have equal slopes. So the slope of a line parallel to this is also going to be negative 3. And that is an important piece of information about our line. We know the slope is negative 3, and we also know that our line contains the point or passes through the point to negative 3. And so what we're going to do now, guys, is take these two pieces of information right here. We have a slope and we have a point, and we're going to write the equation now of our new line in point-slope form. This is the reason I pushed you guys so hard to get used to point-slope form, to not be scared of it anymore earlier in this section, because a lot of the problems that we're going to solve from here on out give you this information, a point and the slope. Therefore, point-slope form is the best one to go to. Just in case you forgot, point-slope form is y minus y1 equals m, and then times in parentheses x minus x1. So let's fill in what we know here, guys. Y minus the y coordinate of our point right over here is negative 3, so that's actually minus negative 3. That becomes plus 3. Equals the slope we just found is negative 3, and then in parentheses it's x minus your x coordinate right here, which is 2. Let me just remind everybody that this 3 is negative. Right here it appears positive. This 2 is positive. Right here it appears negative. Now, I didn't do a great job with my directions right here. What they should have said is find the equation in slope-intercept form of that line here. So right now we have the equation in point-slope form. We just want to put it into slope-intercept. And we talked about this in the earlier section here. We're going to distribute that negative 3 first and get y plus 3 equals negative 3x plus 6. And then we're going to subtract a 3 from both sides, and we should be done here. Let me write this over here. Y is equal to, that'll be a negative 3x, and a plus 6 minus 3 is going to give us a plus 3. And I think that is the answer we were looking for. Now, how do we know? Let's make sure this line does what it's supposed to do. Our line was supposed to be parallel to this line right over here. This line had a slope of negative 3, so our parallel line should have the same slope, and I can see that it does right here, a slope of negative 3. The second thing I want to make sure, honestly, probably the most important one, let me erase all of this junk, is that the point that our line is supposed to contain or pass through is actually a solution to this equation right here. So let's plug it in and make sure it works. Our y coordinate at this point is negative 3, and that should equal a slope of negative 3 times an x coordinate right here of 2, and then plus 3 at the end of all that. So let's see. Negative 3 equals negative 3 times 2 is negative 6. Negative 6 plus 3 is negative 3. So check, that one works out. So, feel really confident in this answer right here. What I'm going to show you right now is in no way necessary for you guys to do, but it is just kind of a quick check that hopefully is going to verify the idea at work here. The original line they gave us was y equals negative 3x minus 2. That has a y-intercept of negative 2. So we'll go down 2 units and put a point there, and a slope of negative 3, which means negative 3 over 1. So that means we're going to go 3 units down and 1 unit to the right, and that's what that would look like. Running out of room, I could also go up 3 left 1, up 3 left 1. I got a little bit more room to do that there. So here, ooh, not very well drawn. Let's try that again. Here is the original line here of y is equal to negative 3x minus 2. Now, we believe that we've come up with the equation of the one and only line that's parallel to that line and also contains the point 2, negative 3. So let me see. The point 2, negative 3 is from the origin, right 2 and down 3. Let's see if we hit that point there when we graph this line. Y equals negative 3x plus 3. Okay, our y-intercept is positive 3, so we go up 3 units and put a point there, and our slope of negative 3 tells us once again to go down 3, right 1. And watch what happens when I do it again. Down 3, right 1. I hit that point right there that I was hoping to hit. So I think that's probably good enough. If I draw the purple line now connecting those collinear points, we should see 2 things. Number 1, is the purple line parallel to the blue line? Yeah, it sure looks like it is. And second of all, does the purple line contain this point of 2, negative 3? And it does. So there's a lot of ways to kind of verify your answer. We kind of verified it algebraically right here, but we also verified it graphically right up here. I don't think it's necessary to do both of those. I'd rather have you guys focus on the algebra right here, but this is kind of a quick little mental check there. Okay, that was example A. I think the next ones we'll go a little faster with. In fact, I'm not even sure I'm going to graph these ones from now on, so let me just move that graph out of the way. It'll be there later if I need it. Okay, this is really the same style of problem right here, but with one major difference. The equation that we were given is not in slope-intercept form. 2x minus 3y is equal to 12, I'm hoping you might notice, is in standard form. Now, the very first thing we did on the last problem is we said, okay, what's the slope of their original line, and therefore we use that to come up with our parallel slope. We're going to do the same thing here, but this one's a little bit tougher. To get the slope out of standard form, what we're going to do is solve this equation for y and put it into slope-intercept. So the first thing I'm going to do is subtract a 2x from both sides, and that'll give us negative 3y is equal to, most of us prefer the x term first, so negative 2x plus 12, and then we will divide all 3 terms here by negative 3. And that's going to get us, let's take a look here, guys, y is equal to negative 2 divided by negative 3 is positive 2/3 x, and then a minus 4 at the end of all that. Now, this is not my answer, guys. This is just their original line here, now put into slope-intercept form. And the whole reason that we did that is so that we can answer one simple question: what is the slope of their line? The coefficient of x here is 2/3. And now that we know that, now I would say, what's the slope of a line parallel to that line right there? Well, parallel lines have equal slopes, so if this slope was 2/3, our parallel slope is going to be 2/3 as well. And where are we right now? We know the slope of our line, and we also know a point that our line has to pass through. So with all that in mind, I'm going to switch to purple now. Let's go to point slope form. Y minus our y coordinate, which is 5, is going to equal our slope of 2/3. And then in parentheses, that gets multiplied by x minus your x coordinate right here, which is 9. So there's our equation in point slope, but I know they want the answer in slope intercept, so we're going to distribute that 2/3 now and get y minus 5 is equal to 2/3 times x is just 2/3 x. Now, minus 2/3 times a negative 9, If you guys needed to, you're always going to be able to go to your calculator here and type in 2/3. You can either do it as a fraction or simply using the division key. 2 divided by 3, that's 2/3. And then if we I don't like what's happening there. It's putting that in the denominator. So let me delete that. Let me hit my right arrow. Okay, 2/3 multiplied by 9, and that's going to give me the answer I needed, which is 6. But I'd really like to encourage you guys not to lean on your calculator too much. The quick shortcut right here, guys, is you can take this whole number, 9, divide it by the denominator. 9 divided by 3 is 3, and then multiply by the numerator. So 9 divided by 3 is 3, times 2 is a way to get 6 there mentally. You don't need your calculator for that. Let's add a 5 now on both sides, and I think we're about done here, everybody. Y is equal to, we've got a 2/3 x minus 6 plus 5 is going to be a minus 1. And I think that's my answer right there. Let's check the two things it needs to do. Number one, is this line parallel to this line here? Well, doing some work here, we found that the slope of this line was equal to 2/3, so the slope of our line should be 2/3 as well, and I see that right here. So I feel pretty good about that. Second of all, and this is the real test, guys, does our line contain the point 9,5? So let's try that one by substituting in. For y, we're going to put in this 5 right here. That's going to equal 2/3 times an x value of 9 minus 1. So 5 equals, here's the same trick we just talked about. 9 divided by 3 is 3, times 2 is 6, and minus 1, 5 is equal to 6 minus 1 is 5. So yep, that all checks out, and I feel real good about that answer right there. Okay, so that's how we handle a problem like that, where the original equation was given to us not in slope-intercept form, but in standard form. And looks like I've got one more example for you right here, guys. This is going to be a test of something we need to practice more of. Find the equation of a line parallel to x equals 6 that contains the point -7, 3. Okay, what this is going to test here, guys, this sounds just like the last couple of problems right here. The difference being that in the first example we did, the equation given to us right here was in slope-intercept form. In the second example, that equation was in standard form. And in the third example here, x equals 6 isn't really slope-intercept form, and it isn't really standard form. What we have right here, guys, is just x equals a constant. No y's involved at all here. So one of the things that we wrote down at the end of our notes in 3.8a is that if you have an equation of the form x equals a constant, this right here is a vertical line. And this number right here is called your x-intercept. We called it a, and the x-intercept of this vertical line is 6. So if I were to graph that real quick, it's pretty quick and easy to do. An x-intercept of 6 means I go 6 units to the right and put a point right there. There's my x-intercept. And a vertical line has no slope, and it just looks like this. That's what the word vertical means. So here is the line x equals 6. Now what we're supposed to do is come up with the equation of a line parallel to that, passing through this point right here. Well, what I want everybody to focus on is this comment that we talked about right here. All vertical lines are parallel to each other. So if I wanted a line that was parallel to this blue vertical line, it's going to be another vertical line as well. And if our line is going to be vertical, then its equation is still going to be x equals and then some constant right here. And this gets really, really easy, guys, once you recognize that. It's x equals a constant, and that constant is going to be whatever your x-coordinate is right here of any point that it passes through. So since this line passes through the point -7, 3, our equation is just going to be x equals -7. And that's it, guys. That's your answer. So as I said at the end of the 3.8a notes, horizontal and vertical lines are actually much, much easier than diagonal lines that we dealt with here in examples A and B, but you've got to know your basic facts right there. That x equals a constant is a vertical line, that all vertical lines are parallel to each other, and that the equation of any vertical line is just going to be x equals a constant. Now, if you wanted to see this drawn out, if we plotted the point negative 7, 3, we'd be going 7 units to the left and then 3 units up right there, and we'd be drawing the one and only vertical line that passes through that point, which would look like this. And again, it's a vertical line, so its equation is x equals a constant, and the number you put here is its x-intercept, which is this point right here, which of course is 7 units to the left of the origin. So x equals negative 7. If you guys study some of those basic things about horizontal and vertical lines, you're going to find they're actually much easier than the quote-unquote normal problems. Okay, let's shift gears now, guys. We're going to move on into the second big topic here in 3.8b, perpendicular lines. Everything we've done so far has been parallel. Perpendicular lines have slopes that are, here's a phrase we need to know, opposite reciprocals. Reciprocal is a word that most people know. It means that you flip a fraction. You switch the numerator and the denominator. And the phrase opposite, or the word opposite, means that you're going to simply change the sign of whatever number you started with. So let's look at a couple of examples here. If a function, or excuse me, if a line here had a slope right here of something like 2/3, the opposite reciprocal of 2/3, we would reciprocate the fraction to get 3/2, but because the original slope 2/3 was positive, the opposite reciprocal would be negative 3/2. Now remember, you can put that negative either out in front or up on top or down on bottom. I think it's usually a good idea to put it up there in the numerator, but that's just me. So that's one example there, guys, of what that would look like. What else? What if your slope was a whole number? Like, I'm going to make it negative, but what about negative 5? Okay, remember that you can take any whole number and turn it into a fraction by putting a 1 on the bottom. So that negative 5 is actually negative 5/1. And when we reciprocate negative 5/1, we're going to get 1/5. The original number was negative, so this opposite reciprocal is going to be positive. So negative 5 has an opposite reciprocal of 1/5. I wanted to point out right there that, a lot of people sometimes get in the habit of using the phrase negative reciprocal, and I think that's a really bad idea, because when you say that my perpendicular slope is a negative reciprocal, that implies that it always needs to be negative. And really the word opposite is more accurate right there, guys, because whatever it was, we changed the sign of it. I don't think I need 3 more examples, but I did just want to talk about a couple of weird ones here. If your original line had a slope of 1, the opposite reciprocal of that, well, let's think about it, guys. 1 is equal to 1/1, and when you reciprocate that, you end up with 1/1 again, which is just 1. Now, with opposites, we do change the sign right there, but it's a little bit weird that the reciprocal of 1 is actually the same number. That's the only number that applies to. And another one I wanted to talk to you guys about is this, and it feeds into the last thing we're going to talk about. If you were going to begin with a slope of 0, you could turn that into a fraction by making it 0/1. And when you go to reciprocate that, you'd get 1/0, but hopefully right away you realize, wait a minute, that doesn't exist. Anything divided by 0 is undefined. So 0 is the only real number that exists that does not have a reciprocal. Its opposite reciprocal, therefore, would be undefined. So, with that idea in mind, this statement right here becomes really, really important, guys. What kind of line has a slope of 0? That would be horizontal, if we remember from 3.8a. And then, a line perpendicular to it would have a slope that's undefined, and that would be a vertical line. So that's where this statement comes from here, guys. Any horizontal line and vertical line are automatically going to be perpendicular to each other. So there's a horizontal, there's a vertical, and if you've drawn this right, that's going to make a right angle. You can't say that the slopes of a horizontal and a vertical line are opposite reciprocals because 0 doesn't have a reciprocal. So that's the tricky thing about that. Okay, let's see what I think 3 examples, guys, and then we're about done. So here goes. Find the equation now of a line, perpendicular to y is equal to 2x plus 5 that contains the ordered pair 4, negative 5. Now, we got lucky here, just like we did on the first one. The equation was given to us in slope-intercept form. So the whole point of getting that line is to know that the slope of this line is equal to just 2. Now on the previous problems, I had you guys drawing this little symbol right here, M with a parallel sign, and parallel lines had equal slopes. Now things get a little bit more difficult, but here's the symbol we're going to use, M with a little perpendicular sign. And if you forgot, the symbol for perpendicular is like an upside down capital T. And so the perpendicular slope now here is going to be the opposite reciprocal of 2. So 2 as a fraction is 2 over 1. Its reciprocal then would be 1 over 2. And since the original slope was positive, our opposite reciprocal is going to be negative. So that is the slope now of our perpendicular line. We know our slope, and we know this point that it passes through. So we're going to go to point slope form again. Y minus our y coordinate of negative 5 actually makes plus 5. That equals our perpendicular slope, which is negative 1/2, times x minus your x coordinate of 4. So there's our equation now in point slope form. Let's distribute the negative 1/2, solve for y, and then we will have it in slope-intercept form. So y plus 5 will equal, that's a negative 1/2 x. I now see a negative times a negative, that'll be plus, and half of 4 is just 2. All we have to do now is subtract a 5 from both sides, and we should be done here, guys. Y is equal to, that's a negative 1/2 x, plus 2 minus 5 is going to be a minus 3, and I believe that's our answer there. Now, what I'd like to do, though, is test this out by drawing, or graphing, I should say, both the original line and our new line, and making sure that it looks like our new line does what it's supposed to do. The original line, y equals 2x plus 5, is going to have a y-intercept of 5 right there and a slope of 2. So I'd go up 2 and right 1, but I run out of room pretty quickly. So I'm going to reverse that now and go down 2, left 1, down 2, left 1, so on and so forth forever and ever. There you go. All right, so that is our original line. And now we want to make sure that the new line that we've come up with right here, all right, should be both perpendicular to that and contain the point 4, negative 5. Let's try it. So our line has a y-intercept of negative 3. So we go down 3 units and put a point there, and a slope of negative 1/2. That means we're going to go down 1, right 2, down 1, right 2, but I'm going to stop there. That's not getting me any closer to that original blue line. I'm going to reverse my field now. I'm going to go up 1, left 2. Up 1, left 2, up 1, left 2. That's probably good enough. And now I am going to draw that purple line that connects all of those points right there and hope that I see 2 things. Number 1, do you guys buy in looking at the graph that the blue line and the purple line are perpendicular to each other? You can't really trust your eye on that, but I think it passes the eye test there, guys. Yeah, that looks like a right angle. And second of all, does our new purple line right here contain the point 4, negative 5? Well, from the origin, I'd go 1, 2, 3, 4 units to the right, and then 1, 2, 3, 4, 5 units down. Yep, there's the point right there, 4, negative 5, that our blue line was supposed to pass through. So the graph doesn't really prove anything, you guys, not formally anyway, but it does make me feel pretty confident that we got this problem right. Let's look at example B. Just like example B in the first part of the notes, now we've been given an equation, in standard form. So we've got to do a little bit of digging to figure out the slope of that line here. So how are we going to do that? Solve for y. Let's subtract a 5x from both sides now, and that is going to get us 3y is equal to a negative 5x plus 12. And then we'll divide every term here by 3, and we will get our original equation now in slope-intercept form. Negative 5 divided by 3, nothing simplifies, so it's just negative 5/3 x, and a plus 4 at the end of all that. So we did all that work. We solved for y so that we could now see that the slope of this original line is negative 5/3. And since we're looking for a line perpendicular to that, the slope of a line perpendicular to this would have a slope that's the opposite reciprocal of negative 5/3. So flip it. That's going to get you 3/5, and it changes the sign from negative to positive here. So this is the slope of our perpendicular line. So we had to do a lot of work just to get our slope, and we also know our point right here. So yet again, we are going to go to point slope form. Y minus our y coordinate of negative 1, so that's y plus 1, equals our slope, which is 3/5, times x minus our x coordinate of 5. Let's distribute that 3/5 there, and we're going to get y plus 1 is equal to, that's a 3/5 x. Positive times negative will be minus, and here we go, guys. Take the whole number, 5, divide it by the denominator. 5 divided by 5 is 1, times 3 is going to get us 3 there. And then we'll subtract a 1 on both sides here. And what's that going to do for us? Those cancel out, and we'll get our final answer now of y is equal to 3/5 x minus 3 minus 1 is minus 4. Now I realized the last problem that I did with you, we verified our result graphically by drawing all this out. Really, what I told you earlier though, the better way to verify this is algebraically. So I'm going to take the time now to double check to make sure that this point right here actually falls on this line. Okay, let's see what we got. Our y coordinate is negative 1. That equals 3/5 times 5 minus 4. So negative 1 equals 5 divided by 5 is 1, times 3 is 3, and 3 minus 4 is negative 1. Yep, that does exactly what I wanted it to do, so I feel pretty confident in that answer right there. Okay, gotcha. Now, from there, one last problem to do before we're done with this section here, guys. Find the equation now of a line perpendicular to x equals 7 that contains the point negative 3, 4. Okay, this is another one. There's a graph here, and I'll come back to that later, but I'd like to do this one without the graph first. Just like example 1c that we did a while ago, x equals 7, because it's just x equals and there's no y there, is a vertical line. Therefore, anything that's perpendicular to a vertical line is going to be horizontal. So since we were given a vertical line, but we want something perpendicular, we know that our line is going to be horizontal. And what does the equation of every horizontal line look like? Y equals some constant. There's going to be no x in this equation at all. And again, making this nice and easy, I'm looking for a horizontal line that passes through this point right here. And since it's y equals, we're now just going to take the y coordinate of this point. And that, you guys, is our answer. Y equals negative 4 is the one and only line that's perpendicular to x equals 7 that passes through this point right here. Let's graph this kind of to show it, guys. X equals 7 is a vertical line with an x-intercept of 7. So it looks like this. Okay, there's the line x equals 7. Now what we want is the one and only line perpendicular to it that contains the point negative 3, so 3 left, and then 4 down, so this point right over here. Well, I'm hoping you guys can see that to be perpendicular to a vertical line, we would have to draw a horizontal line, the only horizontal line that passes through that point of negative 3, negative 4. So it's a horizontal line. Its equation then is going to be y equals, and the number we're looking for is always the y-intercept of that horizontal line. And where does this thing cross the y-axis? At negative 4. So y equals negative 4 is the equation of the one and only line that's perpendicular to the original blue line, but passes through the point negative 3, negative 4. So I'll say it again. Once you learn your basics about horizontal and vertical lines, that vertical lines are x equals a constant, horizontal lines are y equals a constant. And when you're doing horizontal line equations, you use your y coordinate right here. Now, wait a minute. When you're doing vertical lines here, it's the x coordinate that's going to go right there. Once you learn those basics, these problems are actually easier than the other ones that we were doing before. All right, everybody, that is finally the end of the never-ending section of 3.8. So let's dive into that homework and let's see how you do. Good luck, everybody.